Today we're going to talk about extrema, absolute and relative, and critical values. Things are on open intervals and closed intervals. So let's start out. We talk about relative, hang on, there we go, relative or local extrema occur on open intervals. This is key, that this one's open and this one's closed. And absolute or global, I don't know if I've ever called them that, so don't. Okay, absolute extrema occur on a closed interval. And if you think about it, your function, if you graph a polynomial, it goes on forever. How can you have an absolute maximum if it goes on forever? That's why you close the interval, and then you have an absolute. Okay? It says if there's an open interval containing C, on which it is a minimum, then f of C is called a relative minimum of f. Or you can say it has a relative minimum. Why we're repeating ourselves, I don't know. It's also called a local minimum. They are like the low points. It's supposed to say values, but I don't like that. If there's an open interval containing C on which it is a maximum, then C, f of C is called a relative max of f. You can say that it has a relative max at blah, blah, blah. It's also called a local max. They are like the high points. Okay, the extreme value theorem is if f is continuous, which is important, on a closed interval, a, b, then f has both a minimum and a maximum on the closed interval. F must be continuous. All right. Holes do not qualify as max or min. If it has a hole, it's not continuous anyway. All right. Where would the absolute and relative maximum located on the graph? On the interval -2 to 4. So this is a closed interval. Okay. So absolute max is at 421. Absolute min is at -2, -15. A relative max is the high point at 0.5. And a relative min is at 2.1. Okay? It says to determine the absolute extrema of a function, identify the, which makes the derivative and making the equation equal to. Identify the critical points, which means taking the derivative and making the equation equal to 0. Check the domain. I don't know what they want. It says if f prime of C is 0, or f prime of C is undefined, because the bottom equals 0, then C is a critical point of f if f of C is defined. Okay, f of C has to be defined. All right, check where the derivative equals 0. I don't know what they want. Max or mins, I guess. Max or min on the graph results in horizontal tangent lines. Therefore, max and min is where the function is not differentiable. So what? I think we're going to cross that out. That doesn't make sense. Okay, let's do this. Critical points. This is a key word. This is a vocab word. There's a definition. F prime of x equals 0, or f prime of x is undefined. You have a critical point. Okay? Critical value. All right. The absolute and relative maximums. Okay? The absolute min is x equals 3, or you can say the point 3, -2. The absolute max is x equals 6, or the 0.62. Relative max, x equals 2, x equals 4. Relative min, x equals 1, x equals 5. Okay, usually they ask where it is. They want the x value. Or what are the critical values? They want the x value. If they ask for a critical point, I guess I'd give x, y's. Okay. All right, we're supposed to identify the critical points on this function. So the first thing you do is take the derivative, which we're really good at now, 3x squared plus 2x minus 8, and set it equal to 0. I don't know how you factor. This is how I factor. I multiply the 3 times the 8. Now I've got x, I need 6 minus 4 and x plus 6. And since I multiplied by 3, I divide by 3. So I end up with x equals 4/3 and x equals negative 2. Those are the critical points. If they want the y value, you just plug it in, which I didn't do and I don't have my calculator, so you can do that. Okay? Identify the critical points. Is this a continuous function, the cube root function? Yes. What's the graph? Okay. All right, so the derivative is equal to 1/3 x to the negative 2/3. So you end up with negative 2, over 3 times the cube. No, I was right. Hello, I'm hungry, so you have to hang on. All right, so you get negative, 1 over 3 times the cube root of x squared. What makes that undefined or 0? The only thing is x equals 0. If you do f of 0, you also get 0. Okay, so at this point, it's a critical point. It's not necessarily a max or a min. Okay? All right. Because it's undefined. All right. So if it's undefined, you can't have a max or min. It has to equal 0 to be a max or min. All right, critical numbers. So we do 3/5 times 9 minus x squared to the negative 2/5 times negative 2x. So now I get negative 6x over 5 times the 5th root of 9 minus x squared. To find critical points, set the top equal to 0. So negative 6x equals 0. You get x equals 0. And you set the bottom equal to 0. Well, 9 minus x squared has to equal 0. So you get x equals plus or minus 3. And those are critical points. Okay? Candidates test. For closed intervals only, identify the critical numbers where f prime equals 0 or f prime is undefined. Okay, make a t-chart with x and f of x. X candidates are the endpoints and the critical points. This is the key. Highlight this. Endpoints and critical points. Okay, find the associated y points and identify the max and min to the original equation. If the question is asking what, didn't want to do that. If it's asking what, you want the y value. If it's asking where, you want the x value. Okay, where does the max occur? At x equals such and such. What is the max value? They want the y value. Makes sense. All right, identify the absolute extrema on this function. So f prime is equal to 3x squared minus 12. Set it equal to 0. X squared minus 4. So I got x equals 0. And x equals plus or minus 2. Now here's my interval, so I can throw out the negative 2, so I just have x equals 2. Now, to find the absolute extrema, you must make the chart. Must make t-chart. Okay? You want to get an A on your test, you have to have a t-chart. x, y. And you plug in the critical points and the n values, 0, 2, and 4. And you calculate the y value. Plug in 0, you get 0. Plug in 2, you get 8 minus 24, which is what, negative 16. You plug in 4, 64 minus 48. Is that positive 16? Oh, this should be 12, shouldn't it? Oh, y'all are giggling because I can't add. All right, so the absolute extreme of this is the min. This is the max. But you're not going to do that because you're not lazy. You're going to say the absolute min is 2 comma negative 12. Absolute max 4 comma 16. Okay? All right, this one. Multiply it. So you get 2x minus 2. Oh, I forgot the exponent, didn't I? Man, I should go quit and come back and do this later. Minus 1/3 minus 2. And I got to set that equal to 0. So that's 2 over the cube root of x minus 2. Well, if x is 0, this is undefined. If x is 1, you get 2 minus 2 and you get 0. So those are your critical points. I make my chart. I have x and y. I have negative 1, 0, and 1. You plug them in. The cube root of negative 1 is negative 1, but square it, so you get 1 is 3, plus 2 is 5. This is 0. You get 3 minus 2 is 1. Absolute max, negative 1, 5. Absolute min, 0, 0. Okay? Oh, we got to do both of these because they're ugly equations. F prime of x. That's negative 1 minus e to the 1 minus x times negative 1. So it's negative 1 plus e to the 1 minus x. If you want that equal to 0, this has to be 1. So x is equal to 1. And then your chart, x, y, 0, 1, 3. If you plug in 0, e to the first is e, so you get negative e. If you plug in 1, you get negative 1 minus 1 is negative 2. And you plug in 3, you get negative 3 minus e to the negative 2. So which one's smallest? Well, this is negative 2.7 something, and this is negative 3 point something. So this is your minimum, okay? And this is your max. And you're going to get answers like that without a calculator in your hand. It's kind of hard now because you're at home and you got a calculator. But on the AP exam, this question would be on the non-calculator part. You have to know this stuff, okay? Find the absolute extrema. You got to do the product rule here. So you have the first one times the derivative of the second plus the second times the derivative of the first. So this is 6t over 3 times t plus 4 to the 1/3 plus 3 times t plus 4 to the 2/3. If I want to get a common denominator, I multiply top and bottom by that. So this is 6t plus, when you multiply this by 3t plus 4 to the 1/3, these add. So you end up with t to the plus 4 times 9. So you get 9t plus 4 times 9 is 36. Okay. My interval's from negative 5 to 3, so this is never going to be, will that ever be 0? Your t value has to be negative, so it's not going to be in my window. This is going to be negative 4, okay? So go from negative 3, negative 4, and negative 5. Those are the kind of thought process you guys are having these days, okay? And then you do the math and figure it out. Okay, let's talk about these two. The derivative is the cosine of x minus the sine of x equals 0. The only time this function is going to equal 0 is when cosine and sine have the same value, and that only happens at pi's over 4s. And so I got pi over 4, and I have 5 pi over 4. So my chart is 0, pi over 4, 5 pi over 4, and 2 pi. X, y, you plug in 0, so that's 1. Pi over 4, you get root 2 minus plus root 2 over 2. So you have 2 root 2's over 2, so that's root 2. This is negative root 2, and this is 1. There's your min, and this is your max. Okay, do the same thing here. And the very last one, it asks you if it has extrema on it, closed at A and open at B, just like the picture. And this can be a minimum. That can't be a max because it's a hole. Okay, so you have no max, you have a minimum at A. And that's all I got for you. Go back and work these. Do the math on this one. Okay. Alrighty. Later.